wanted to show you about the particle collision. I wanted to talk about this maybe about 3 months ago, but I don't have time. So today I have time, and about the collision, the first I will say the collision is about collision inside the particles, and another part is that collision between the particles and the objects. So there are two parts. So this tutorial I separate them into these two parts. So this tutorial is very easy, and let's begin. Okay, let's go to Blender 4.3, and here first we need to delete the cube, and so we need to build a particle system with geometry node. First, this small plane, I call it emitter. So I will use it to emit the particles, and we need to first, I think, save this project. So this is the English version, that's okay. And the second, I will need an object for the particles to collide with. And so let's finish our first step, and let's go to geometry node, and let's choose the emitter above here. Press new, we have a geometry nodes. So here first build the particle system. I think most of you know how to do that. So we need to first distribute points on faces, and simulation. So connect it to output, and we want every frame we have particles emit from the plane. So we need to join every frame particle from here. So let's go to the spreadsheet and go to point. We have 40 for now. If I press plane, look, it will be 380. So it's working. So then we need to make it move. So we need a set position. So let's try every frame 0.1. So let's check the result. So it means it's working. So this is the basic structure. And then next we will show you how to build the collision system. So we need to put it here. So first here, sometimes you may need some initial velocity. If it's not a plane, if it's like a ball, we maybe want the particles to emit along the direction of the normal. So sometimes we need to use this. Just save the normal as the initial velocity. And you can save others like noise. It depends on you. This is just a demonstration. Okay. Here we need a mass vector to scale this vector. Maybe 0.1. And name it v. It means velocity. So let's go here. And let's use named attribute. Let's choose v and put it here. Let's check. It's going up. So we want it to going down. Okay, velocity is okay. And then we need to build the gravity. So we need a mass vector. If you have learned that, I don't know, the gravity is like 9.8, but here it doesn't have to be like that. You can just set a random number like this. It will be velocity, be the gravity. So maybe it's not very obvious. So that's okay. We just want the effect. So let's begin to make our collision system with the ball. So this is the first collision system. So we need to drag the ball here and put it to relative. So if you have scaled the ball, remember to apply all transform. And then here, the key node we use here is ring. I think Blender built this node accurately for collision, but it's not working very accurately. So I will show you in the end of this tutorial. It works well here, but not perfect. So we put object to target geometry. Then we need to give the redirection. So here redirection is the initial velocity and adds the gravity. Put it here, and then it needs a ring length. So we need to just copy this and change it to like length. Yes. Connect it here and connect it here. So we have ring length. So here this node works when you connect all these 3 sockets. So it will charge if the particle collide with the ball. So it will output if hit, and we will use that to switch the vector, to switch the force. We change it to vector. So is hit connect to a switch. So put it here, make more space. So we will see if it's not hit, if it's force, we need the velocity go like this, and we will see if it's hit, we will need to reflect. So how to reflect? There is a node for reflect here. Reflect. This node, this mass node, is specially designed for reflect. So we need to connect the initial velocity. I mean the initial velocity and the gravity. And we need a vector that for them to reflect. So that's hit normal. Hit normal means if this is a point hit with the sphere, so there is a normal in the surface of the sphere. So that's this normal. So this mass node will calculate the new vector according to this normal and the initial velocity. I will draw it like this. If this is normal, if this is initial velocity, it will go like this. So that's how it works. So we have connected all these nodes here and connected this to here. Okay. So it will be like this. So let's check the result. Let's check. There is something happened here, but not very obvious. Yes, there is something happened. That's right. So maybe we add the velocity. Let's check. So maybe the velocity is too big. Let's try. Here we made a mistake that we need disconnect here. We need to go like this. The initial velocity set their position, and here we will store need attribute. Oh no, not this. Store need attribute here. Connect it to value here. Change the value v. So it will be like this. So it happened. Why we connect like this? Because first we want it to move like this, and after it moved, we need to begin to like check if it's collide with the sphere. So that's a principle. So we can't make it together. We need to update the velocity every frame. So if we just do it in set position, it won't update it. So we need to do it like this. And now we see that the collision is too much big, too much severe. So we need to reduce the gravity and the initial velocity, I think. So let's check it again. Yeah, it will be like this, and you may think it's too regular. It's we need it to be random, so we need to add a scene time here connected to seed. We need a frame connected to seed. Change every frame. So this looks random and looks organic. So first step we succeed. Yeah, we need to make it clear so we can join them together. So we call it collide with object. So let's go to next step. Is collide with the collide with itself. So here there is another set position here because we want to move the particles. This is a must. And the key node here is the index of nearest. So this node ensures us to find the nearest point of the particle system. And I will explain to you like this. If there are 2 points, they collide with each other, and this is the center of them. We can, if this is the point, original point, and we find the nearest, we can find the center position of this point, and with these two positions, we can get the distance between them and compare the distance with the radius, so we can know if they are collided. So if they are collided with each other, we can use a vector calculated from the two positions to get them apart. So this is the main principle. So let's do it step by step. You will know what I'm talking about. So with this index of nearest, we need to sample this index because this only output the index. So we need to sample what's in that index. So connect index to index, and we need to get the position of the index. So here is the position connected to value and change it to vector. So we need a source geometry. So it's itself. We need to connect it here. So this is finished for this node. Very important. Find the nearest. Maybe I spelled it wrong. It's okay. So then we will calculate. First, we need to calculate the vector. We need to subtract. We need to use the position to subtract the nearest position. We get a vector between two objects, and we have direction and the length at the same time. So here, to confirm if they are collided, so we need to have the length. Use the length to calculate the length of the vector, and we need to compare it with the radius. Where is the radius? So this is the radius. We need to use a mass node, I think. Mass, where is mass? Connect here. So this is 2 multiply mass, 2 multiply radius, 2 radius. So we compare that. So float less than. So if A is less than B, so this result output 1, output 2. So then we will need to switch between two vectors. This will change if the point will have an extra vector for it to move. So if it's true here, if it's less than radius, it means they are collided, so it's true. So it needs to be moved. We need make more space. It needs to be moved. So here we need a scale here and link to true. So we'll change it maybe to 0.2 just for test and connect to offset. So then it will have like this. It's still too strong. I think I need to check the value why it's so strong. So if it's too strong, I think maybe reflect we need here add a scale to make it smaller, 0.5. If they are collided, the value will decrease. Yeah, this is smaller. So you can try this. So here I will join them. So I will rename it. So client inside. So I will show you if it's working. So we will use instance on point to check the result. Instance a sphere. No, not this. A sphere. Radius 0.5. And at the beginning here, we need to set the radius. It's 0.5. It's too small. I want to demonstrate if it's working. So we need to increase it. Ensure these two values are the same. So we find that here it's collided with each other, and downside they are not collided. So let's make the value bigger. Let's check the result again. So you can see here, it's working. It's definitely working. So you can decrease the value, make it smoother. And let's see, you can make decrease the radius 0.1. And here 0.1. Make sure that these two values share the same value. Yeah, you can see it's working. It collided with itself and it collided with the ball. And the last part I will say why it's not perfect. So I will show you very simple. Here we need a grid. Oh no, not grid, sorry. A plane. Put it here and apply it. Go to emit and drag it here. And change it to relative. And I will join these two objects. So you can see it's working, but it's not working very well. So this is the problem that this recaster node is designed for collision, but it's not very perfect. When the velocity is too much small, it's not working. So instead of manually invent some node systems for collision, I prefer that Blender will someday to make the recaster better or create a new node just for particle collision. So this is today's tutorial, and thank you for watching. Thank you for supporting me. See you in next tutorial. Bye bye.